Today we're going to be covering the product rule, quotient rule, and chain rule. These are all rules for derivatives. So I want to introduce it to you. Let's say that we have this function f of x, and we wish to find f prime. We want to find the derivative of f. So what I would do on this, if I was asked to find the derivative, I would begin by changing that. I would distribute the 6x through, change it to a polynomial, and from there I would use the product rule. The power rule. The power rule. So 2 times 12 is 24. Keep your x, reduce the power by 1, plus the derivative of 18x is just 18, and I'd be done. So that is the derivative of f, and I know that that is true. So my question is, could we have done this a different way? Could we have taken the derivative, where are my colors? Could we have taken the derivative of x, of the first term, and multiplied it by the derivative of this inner term? So question, would this be the same as the derivative of 6x is 6 times the derivative of 2x plus 3 is 2? That would give us 12. Did we get the correct answer? No. 12 is not this. So this process does not work. I need you to know that. When you have a product of functions, you cannot just take the derivative of each and multiply it together. It does not work, okay? So the derivative of the product of two functions is not the derivative of that. So it's not the product of the derivatives, okay? That is not true. Instead, we have what's called the product rule, and it is not just take the derivative of each piece and multiply it together. Okay? Doesn't work that way. So the product rule, I'm just going to give you the rule. So here's how the product rule works. So this will be when you have a product of two functions of x. X is here, x is here. Okay? We're going to start with the first function and take its derivative. Then we're going to multiply by the second function left alone, plus, now we do the other set, the derivative of the second function times the first function left alone. That is the product rule. Okay? Now, since there's a plus, we totally could have switched those, but I like to start with whatever is first and take its derivative first. Okay? If you do that, it'll help you with the quotient rule that's coming. Okay? All right, the quotient rule. Also, before I go to the quotient rule, since these two pieces are being multiplied together, we could have switched those as well. But I don't. The first function, I take its derivative first. Okay, for the quotient rule. First of all, the quotient rule is a quotient. So you get a fraction. Okay, the quotient rule gives you a fraction, a quotient. You're going to start up on top. That function, you take its derivative first. Then you multiply by the bottom function left alone. Sound familiar? Yeah. The quotient rule has a minus here. And then we do the other pair. So the derivative of the bottom times the top function left alone. So that is the numerator. It is almost identical. The numerator of the quotient rule is almost identical to the product rule. The only thing that's different is the sign. Okay? In the denominator of the quotient rule is this denominator. So whatever's on the bottom, it is there. Left alone, no derivative, but you square it. No derivative, but squared. I call this the bottom left alone, but squared. Okay, that's the product rule and quotient rule. Let's do some examples. Okay, find the slope of the line tangent. That means derivative. That's derivative. One of our meanings of derivative of this function at the point when x is 1. This is a quotient. It is a quotient, right? So I am going to find the derivative, I'm going to start on top. We always start on top. And take its derivative. So the derivative of the top is 2x. Multiply by the bottom left alone. Minus is in the quotient rule. Now we take the derivative of the bottom and multiply by the top left alone. The denominator of the quotient rule is the old denominator, x minus 3, but squared. Now we're going to plug in 1 for x. So we have dy dx at x equals 1. Okay? And so we're plugging in, that's notation for the derivative of y with respect to x at x equals 1. Plugging in 1 for x, so we're going to have a 2 times a negative 2 minus 4 minus 2, I'm sorry, 1 minus 4 is negative 3. And then on the bottom we have 1 minus 3 squared, so that's going to be negative 2 squared. You guys, these two things will always match because that is g and this is g. If we just square it on the bottom. Okay? So this gives us negative 4 plus 3 over 4, so that gives us a negative 1/4. This is a good time to show you something that your calculator can do. So let's go pull out your calculator. Okay. I am finding here the derivative of y at the point 1. X is equal to 1. So at the point when x is equal to 1. All right. So there's a derivative feature on your TI-84. It is under the math button. So if you push math, and then down here on number 8 is n derivative. That means numerical derivative. Your calculator is using a process, an algorithm to find this derivative, all right? So because of that, because it's a numerical method, it will stop computing as soon as it reaches whatever tolerance level was programmed into this calculator. So this calculator might give you a slightly different answer than a different calculator would, and we have to be able to interpret that. If we get an answer of 0.50000000173, we have to interpret that as 0.5, a half, all right? You're going to see sometimes, many times, you'll see a little error back in the back, okay? Just interpret it. Okay, so here I'm going to go down to number 8. You can either scroll down or you can just push the 8 button on your calculator. I always just push the 8 button on my calculator. So I'm going to do 8. We call it Math 8. Math 8 is derivative. We're taking the derivative with respect to x of, inside the parentheses goes our function. I'm going to make this look just like what it says on my paper by using the F1, the fraction template feature. It's either under F1 or some calculators have it. If you do alpha x here, alpha x, it gives you the fraction template on some calculators, on the newer ones. Otherwise, it's under F1, okay? My calculator allows me to do alpha x and get that fraction template, and that's quicker for me than going to F1. So, x squared minus 4 on top, x minus 3 on the bottom. And we are evaluating this when x is 1. So we're going to put 1 in for x. And that's what the calculator gave me. Negative 0.2500003125. That's the error. The actual derivative is negative 1/4, which we know. We know it's negative 1/4. Okay, so that's how you can do this on your calculator, too, to check yourselves. Or, if it was a calculator active problem, you could just use your calculator for that. All right, number 2 here. This time I see a product. I see a product. I see x's times x's. It's a product of x's. If this first x was a 3 or a 2 or a 17 or a negative 5, I would not have to use the product rule. But since it is an x, we have to use the product rule. So for the derivative, I first take the derivative with respect to x, and then you plug in pi over 6. Start with the first function and take its derivative. Its derivative is 1. Multiply by the second function left alone. Plus. Now we need the derivative of the second function, which is negative sine x. Multiply by the first function left alone. So this gives us cosine x minus x sine x. Now I'm going to plug in pi over 6 for x. So we're communicating what we're doing. This was h prime of x. This is h prime of pi over 6. Cosine of pi over 6 is square root of 3 over 2. X is pi over 6. Sine of pi over 6 is a half. They got a common denominator of 12 here, so I'm going to get a common denominator of 12. 2 times 6 is 12, so I need to multiply the square root of 3 times 6. 6 over 12 is still 1/2 minus pi. So 6 square root of 3 minus pi, so that'll be b. Number 3. Find the instantaneous rate of change of w, which is a quotient. And again, you guys, if this x was just a number, I would not use the quotient rule. You could use the quotient rule, but you don't have to if it's just a number. But since it's an x down here, we need to use the quotient rule. So I'm going to. First of all, it yields a quotient. Start up on top and take its derivative. The derivative of sine x is cosine x. Multiply by the bottom left alone. Minus is in the quotient rule. Now we take the derivative of the bottom, which is 1, and multiply by the top left alone. In the denominator of the quotient rule is the denominator squared. So as a multiple choice answer, this would be x cosine x minus sine x over x squared. And that would be it. These x's do not reduce because there's no x over with the sign. Number 4, another quotient. So first we're going to use the quotient rule, and then we'll plug in 2 for x. Start up on top, take its derivative. The derivative of the top is 2x plus 1. Multiply by the bottom left alone. Minus is in the quotient rule. Now the derivative of the bottom, 2x, times the top left alone. All divided by the bottom left alone, but squared. Now we plug in 2 for x. We're going to have 5 times 2 minus 4 times 4 plus 2 is 6, minus 1 is 5, over 4 minus 2 is 2, squared is 4. So that is 10 minus 20 over 4, negative 10 over 4, negative 5 over 2. Negative 5 over 2. Again, you guys, we can check this on our calculator. Math 8 with respect to x. of x squared plus x minus 1 on top, x squared, not negative 1, x squared minus 2 at x is equal to 2. Negative 2.5. That's how I would interpret that answer. Okay? Negative 2.5. Alrighty, number 5. Slope of the line tangent to this. If you were in class, I would have you do this together with your group, but you're not in class, so here we go. We're going to use the quotient rule. Quotient rule. Start up on top and take its derivative, 4x cubed. Multiply by the bottom left alone. Minus is in the quotient rule. Now the derivative of the bottom. The derivative of the bottom, self-centered secant, secant x, tangent x, times the top left alone. All divided by the bottom left alone, but squared. Right? Okay, this time, there's a common secant up here, which can reduce with this secant down in the bottom, with one of the secants on the bottom. I'm going to factor out a secant x. Factor out a secant x. Now reduce one of those secants with, or one of these secants with that secant. So this would be 4x cubed minus x to the 4th tangent x over a single secant x. And that is answer choice C. Okay, that's the product rule and quotient rule. Let's do a problem in a different form. What if I gave you, instead of giving you the equations, what if I gave you the graphs of f and g? So f and g are shown, and p is f times g. Which of the following statements is true about p prime of negative 2? So first I'm going to find p prime of x. It's a product, so I start with the first function, take its derivative, multiply by the second function left alone, plus for product rule. Now we need the derivative of the second function times the first function left alone. And now they ask me to consider p prime of negative 2. So p prime of negative 2, we're not going to be able to find these exact numbers, but we can find their signs, right? And that's all we need to do to answer this question. Okay, so f prime times g plus g prime times f. And we're going to the graph where x is negative 2. Where x is negative 2, we're right on the x-axis there, and negative 2 here looks like it's around that point. Okay? So, f prime of negative 2. F prime is the slope of that tangent line, and the slope of that tangent line is positive. G of negative 2. G of negative 2 is negative because G of negative 2 is below the x-axis. So that is negative. G prime of negative 2. G prime of negative 2 is the slope of the tangent line there. So that is positive. It's a positive slope. F of negative 2 is 0. So we've got a positive times a negative plus a positive times 0. That's going to be 0, so we're left with a negative. So this answer would be A. In class, I had the kids do the next one with their group. But, again, you're not in class, so we will do this together. Alrighty, so same setup, just a different x value. So we're still going to have f prime times g plus g prime times f, right? And this time we're considering 1 for x. So I'm going to go where x is 1. X is 1 here. X is 1 just below the x-axis over there, it looks like, right? Okay. Once again, we're going to examine these signs. Okay. F prime at 1. f prime is the slope of that tangent line. That is negative. It's a negative slope. G of 1 is below the x-axis, so it is negative. G prime at 1, well, the slope of the tangent line there is positive. F at 1 is above the x-axis, so it is positive. So we have a negative times a negative plus a positive times a positive. That's a positive plus a positive. This is greater than 0. So the answer to this question is C. Okay. In class, I had the kids take a little break at this point, but we're going to go straight into the chain rule. The chain rule. So first of all, when to use the chain rule. Let me get out my little sheet, my little intro sheet here again. Where's my intro sheet? I'll just get a new intro sheet. Okay, intro to the chain rule. So if I had f of x is equal to 3x plus 7 squared, and I want f prime of x. Well, the first thing I would do is to square this binomial. And if you square this binomial, you get 9x squared plus 21x plus 21x, so that's 42x, plus 7 times 7, 49. And then I would take its derivative using the power rule, so 18x plus 42. So that works great for if you're squaring a binomial. However, what if it wasn't squared? What if it was raised to a higher power? What if it was raised to a much higher power? Then that process would be extraordinarily tedious. That's where the chain rule comes in. Okay, this would be a chain rule problem. When to use the chain rule? When you have something in parentheses raised to a power, okay, or when you have a function like sine, cosine, natural log, e to the x, e to a power, a function with not a plane x, if you don't have a plane x. So whether you have parentheses to a power or a function whose argument, this is the argument, and if the argument is not a plane x, then you use the chain rule. Okay? Here's how the chain rule works. You always start on the outside. You start on the outer function, and take its derivative. You leave the argument alone. Leave the argument alone. No derivative of its argument. Then you multiply by the derivative of the argument. So g prime. Okay. So the derivative of the outside of whatever was inside stays inside. And then you multiply by the derivative of the inside. So I always like to tell kids the last thing you do is take the derivative of the inside. Okay? Let's do some examples. All right, number 8 here. Okay. Find the slope of the line tangent. That's derivative of y in terms of x. So I see a trig function with not a plane x. So I know this is chain rule. So I start on the outside. The outside here is sine. That's what's on the outside. Take its derivative. Here's your f prime. Take its derivative. Derivative of sine, cosine of whatever was inside stays inside. The 3x stays inside. And then you multiply by the derivative of the argument, the derivative of the inside, so 3. The last thing we did was take the derivative of the argument. We're done. So as a multiple choice answer, this would be 3 cosine of 3x. Number 9. I see parentheses to a power, so I know this is chain rule. Okay. On the outside is a 4, but on the outside is a power of 7, too. So we're going to use this power rule. 7 times 4 is 28. Keep your inside. Keep your inside the same. Decrease your power by 1. It's the power rule. We decrease the power by 1, right? And then the last thing is you multiply by the derivative of the inside. And the derivative of the inside is 15x to the 4th minus 6x squared. And that's the derivative. Chain rule. Number 10. Number 10. Hang on just a sec. I am making this video at school. I always make it at home where it's nice and quiet, but I hear some noise out in the hallway right now. Anyway, sorry if you heard that too. Okay, find dy dx. So this time it is a quotient, isn't it? However, up on top is just a number. I personally tend not to use the quotient rule when there's just a number up on top, okay, or on the bottom. It's easier for me not to use the quotient rule if there's a number on top or on bottom, okay? So I'm not going to use the quotient rule, even though I could. Instead, I'm going to bring this to the top and give it a negative power. So I'm going to rewrite f as x squared plus 4 to the negative 3 power. And now I'm going to use the quotient rule. Negative 3 times the front. Keep your parentheses the same. Decrease your power by 1. Multiply by the derivative of the inside. As a multiple choice answer, they would probably write this as negative 6x, because negative 3 times 2x is negative 6x. Then they would probably pull this to the bottom again and give it a positive power. Multiple choice answer. Number 11. Again with number 11, there's just a number on the bottom, so I'm not going to use the quotient rule, even though I could, all right? Instead, I'm going to rewrite this as 1/4 secant of 2x. I have a trig function with not a plain x, so I know this is chain rule. Y prime of x will be, this 1/4 just stays 1/4. There's no x in it, so it's just a 4th. The derivative of secant is secant tangent, but we keep the same argument. Secant 2x, tangent 2x. Then the last step is to multiply by the derivative of the argument, like that. So guys, whatever your argument started out to be, our argument started out to be a 2x. Every argument for the trig functions will be that 2x. 2x and 2x. That will stay the same. As you take its derivative, it keeps the same argument every time. Okay, now I'm going to plug in pi over 12 for x. When we multiply a 4th times 2, we get 1/2. So I'm going to write that as a half. And then I have secant of 2 times pi over 12, that's pi over 6. Tangent of pi over 6, that is 1/2 times, okay, secant of pi over 6. Well, cosine of pi over 6 is square root of 3 over 2, so secant of pi over 6 is the flip of that, the reciprocal of that. So I just flip it. Tangent of pi over 6 is square root of 3 over 3, 2 3s and 6, right? Some nice things happen here, and we are left with 1/3. So that answer is 1/3. Shall we see what our calculator gives us? Let's see what our calculator gives us. Math 8 with respect to x. I guess I'll do this. Secant. Secant is 1 over cosine, right? 1 over cosine of 2x. And then we have this 4 in the bottom, right? So, I didn't have my closed parentheses there. Okay. So that's secant of 2x over 4, and I'm evaluating that at pi over 12. 0.333334888. So there's the error. There's the error, and do you see the 1/3? I see the 1/3. Okay. Number 12. Find h double prime of x. All right. So h double prime is the derivative of h prime. Yeah? In class I did this. I said if f of x is, let's say, x to the 6th, what is f prime? 6x to the 5th. What is f double prime? 30x to the 4th. What is f triple prime? 120x cubed. What is f quadruple prime? Okay, we don't keep on writing hash marks. We don't keep on writing primes. Once we get past the third derivative, it's the fourth derivative. However, if you write it like that, this says f to the 4th power. We don't want f to the 4th power. We want the fourth derivative of f. So we put that in parentheses. That is the notation for the fourth derivative of f. So this is 360x squared. The fifth derivative of f would be 720x. And the sixth derivative of f would be 720. What would the seventh derivative be? 0. What would the eighth derivative be? 0. All subsequent derivatives would be 0. Do they exist? Yes, they exist. They're all 0. Yes. Okay? So you might be able to see this, the factorial process going on. 6 factorial is 720. Okay? That's how you take higher order derivatives. Okay, so h prime of x. It's just a 3, just a 3. Derivative of tangent is secant squared. Okay, you guys. Now we need to take another derivative, and I'm taking the derivative of this. You guys, every time you have a trig function to a power, please rewrite it as the trig function all to the power. That will help trigger your head to say, oh, this is definitely chain rule, okay? So do that. Trig function to a power, write it as the entire trig function to that power. Okay, so now this derivative, 2 times 3 is 6. Keep your inside, decrease your power by 1, and now take the derivative of the inside. Derivative of secant x is secant x tangent x. The argument always stays the same. As a multiple choice answer, this would be written as 6 secant squared x tangent x, because there are 2 secants. Okay, number 13, slope of the line tangent to this graph, to this function. So I see a trig function to a power, so I'm going to rewrite it as the trig function all to the power. Okay, now we do the chain rule. 3 times 2 is 6. Keep whatever was in there stays in there. Reduce your power by 1. Now we need the derivative of the inside. So the derivative of cosecant is negative cosecant cotangent, but we always keep the argument. So cosecant 5x plus 1, cotangent 5x plus 1. Whatever was the argument stays the argument. The last thing you always do is take the derivative of the argument. Always do. Once you take the derivative of the argument, you're done. So this as a multiple choice answer. I see a 6 times a -1 times a 5. That'll be a -30. Okay, how many cosecants are there? I've got 2 cosecants here and 1 cosecant here. So that is 3 cosecants. How many cotangents? Just that one. That would be the multiple choice answer. Okay, let's do this one. I see a trig function to a power, so I rewrite it first. So 5 times tangent of 4x squared minus 3, all to the 4th power. Okay. Power rule, get a 20, keep your inside the same. Reduce your power by 1. Now the derivative of the inside. Well, the derivative of tangent is secant squared. Whatever was the argument stays the argument. The last thing you do is multiply by the derivative of the argument, 8x. Multiple choice answer, 8x times 20 is 160x. We've got 3 tangents and 2 secants. Multiple choice answer. Okay, number 15. All right, once again, we could use the quotient rule, but since it's only a 5 up on top, I am not going to use the quotient rule. I am going to rewrite f as 5 times x squared plus 3 to a negative 1/2 power. It's a square root, so negative 1/2 power. And now I'm going to use the chain rule. Negative 1/2 times 5 is negative 5/2. Keep your x squared plus 3, reduce the power by 1. And then lastly, multiply by the derivative of the inside, 2x. Okay, we're plugging now 1 in for x. So I have negative 5/2 times 2x, but x is 1, right? So that's just going to be, the 2's will reduce out, and I'm going to be left with negative 5. Yeah? Let me do that slower. Negative 5/2 times, I'm just going to do it slower in pieces. I'm putting 1 in for this x, so I get a 4 to the negative 3/2, and then this is multiplied by 2. Now these 2's cancel, right? So I just have a negative 5 on top. 4 to a negative power, I bring it to the bottom, give it a positive power. The square root of 4 is 2. 2 cubed is 8. So this is negative 5 over 8. Okay, how are we doing on time? Alrighty. This was a block day lesson for us. Okay, number 16. The graph of f is shown. It is a piecewise function composed of 2 line segments and a quarter of a circle centered at 5, 3. There's the center. Okay, find f prime of 1 if it exists. Well, I go to where x is 1. F prime is the slope there. What is the slope of that line? The slope of that line is 2 because I go up 2 over 1. Slope of that line is 2. So f prime of 1 equals 2. F prime of 2. Well, when x is 2, I see a cusp. So f prime of 2 is non-existent. It does not exist. Since, you could also say DNE if you prefer. Since f has a cusp at x equals 2, or when x is equal to 2, at or when. Okay, you must state the name of the function where the cusp is, and you must state the x coordinate where the cusp is. All right, those are required in this explanation. Okay, part C. Find g prime at negative 1.5. I see with something that is going to require the chain rule. 2 times 3 is 6. Keep your inside. Decrease the power by 1. Multiply by the derivative of the inside. The derivative of f is f prime. The derivative of 2 is 0. And now we're going to plug in negative 1.5 for x. So let's see, negative 1.5. So f of negative 1.5, and here's negative 1.5, right? F of negative 1.5 is a half. F prime of negative 1.5 is the slope right here, and that is negative 1. This is 6 times 5 halves times negative 1, and that is negative 15. Okay, so this is a big day for us. Product rule, quotient rule, chain rule. Big, big day.